Hi guys, welcome to the third problem of vertical throw. If this is your first time that you're watching this video, okay, please, I need to tell you that this is a video that is in a playlist that contains all the topics of the course of Physics 2. So I recommend you to subscribe to your channel. Okay, so the problem says a person throws a stone vertically downwards. Okay, so this will be the first time that we're going to see downwards, because remember that in the explanation of the topic we saw vertical throw upwards and downwards. So this is the first time at minus 20 meters per second and hits the ground with a velocity of minus 45 meters per second. So the first question, how much time did the object take to hit the ground? And the second question, how much distance did the stone travel? Okay, so let's make the drawing, guys. Let's go to the other screen over here. So let's say that this is a person. This is the person. Okay, and it's going to throw a stone vertically up downwards. But then it says that it's going to hit the ground. So that means that this person must be on a building or on a cliff or something, but the ground is over here. Okay, so the stone is going to be doing something like this. This is the direction that it's going to take, and finally, boom. Okay, so at this point over here, I got, well, before I continue, there is no two segments, only one segment, because the object is not going up and then goes down. No, in this case, the object just goes down. So this is the initial position. This is where the motion starts. Okay, so this is the height. Okay, the height. And this is where the motion ends. And this will be the final position. And the final position is the height of the ground. Okay, that's the ground level. So it will be 0 meters. Okay, so that will be the height. And in here, I'm going to have the initial velocity that in this case is minus 20 meters per second. Okay, and here I'm going to have the final velocity that is going to be minus 45 meters per second. You need to realize the final velocity is greater because we have acceleration. Acceleration, remember, that is the change in velocity. So acceleration is gravity, that is minus 9.8 meters per second square. Okay, and also, well, I'm gonna have a time, the time that takes this object to go from here to the ground. Okay, and well, I believe that's all the data that I have. Now let's write the formulas. Remember, there is only one segment here in this type of problems. So acceleration equals final velocity minus initial velocity over time. That's the first equation. And the second equation, final position equals initial position plus the initial velocity that multiplies the time plus the acceleration that multiplies the time square over 2. Okay, so let's check. Let's see what I have and what I don't have. Acceleration, yes. Final velocity, initial velocity, yes. Time, I don't have time. So from this equation, I'm going to find the value of time. So let's isolate. And time will be final velocity minus initial velocity over acceleration. Okay, so let's substitute the values. Final velocity, it will be minus 45 meters per second minus because the initial velocity is negative, meters minus 20 meters per second Well, I don't know if you are new here in the channel, but remember that the negative sign tells me the direction. Remember the reference system. Everything that goes up is positive, everything that goes down is negative, okay? So that's why it's negative. Over the value of the acceleration, and the acceleration is minus 9.8 meters per second square. Remember that the acceleration is negative because the acceleration goes down, the gravity goes down. So let's get the calculator. Let's answer this problem. Fraction minus 45 minus parenthesis negative 20 parenthesis over minus 9.8. Okay, so let's see how much is that. Well, that is the time, and remember this is an infinite value. Okay, so I'm gonna save it in my calculator, in my calculator. So I'm gonna press shift STOA, so the value got saved in the memory A. So I'm gonna write it 2.55 10 seconds. I'm gonna circle it, and I'm gonna say that this value is already saved in the memory A of my calculator. So that is the first question. That is the answer of the first question. Now let's see how much distance did the storm travel. Okay, well, I know that the final position is 0 meters because that's the height of the ground. So I need to find the height, okay, the initial position. So let's go to the equation over here. So final position, no, well, sorry, yes, it's 0. This one I don't have it, I need to find it. Initial velocity, yes, I have it. The time, I already found it. The acceleration, yes, that's a constant value, that is the gravity, and yes, I got this one. So let's cancel everything that is 0. So the only thing that is 0 is the final position. So I need to isolate initial position. So what I'm going to do, I'm going to move this one to the left. Okay, if I move it to the left, it's going to get the negative sign, of the opposite sign. Okay, so it's going to be something like this: minus initial position equals initial velocity that multiplies the time plus acceleration that multiplies the time square over 2. And this is the equation that I'm going to use. Just realize that this negative, okay, I need to get rid of that negative, but I'm not gonna do it right now. The thing that I'm going to do is that I'm going to solve this equation, and at the end I'm just going to multiply the answer by negative. Okay, so minus initial position equals the initial velocity, that is minus 20 meters per second, that multiplies the time. How much is the time? 2.55. 2.55 seconds plus minus 9.8 meters per second square times 2.55 seconds raised to the square over 2. Remember, initial position, according to my drawing, initial position must be positive because it's above 0. Everything that is below 0 must be negative. This is 0, okay? And the initial position is above, so it must be positive. So the answer that I get here is it needs to be negative. And at the end, I'm just going to switch the sign, so it has to be, so it can be positive. So let's do it. Minus 20, that multiplies the value that I got saved in A, that is the time, plus fraction negative 9.8 times the value of A raised to the square over 2. Okay, and I repeat, must be negative. Boom. Yes, it's negative, but this negative this negative, I'm going to move it to the other side. So I'm going to multiply the final answer, and this final answer I'm going to multiply by the negative, so it's going to become positive. So it's going to be 82.9081 meters. Okay, meters, because seconds got eliminated with seconds, second square got eliminated with second square. Okay, so this is the height or the distance that the stone travel. Okay, so this was the third problem of vertical throw, but in this case it was vertical thrown downwards. In the next video we're going to see the horizontal throw, and I hope I see you in the next video, guys. So take care. Bye bye.